walks onto stage. Good whatever, lady and gentlemen. The problem with the Monty Hall problem is pauses. Monty Hall smirks. You will find the Monty Hall problem, sometimes referred to as the Monty Hall paradox, refers to a mathematics problem. The problem is with a name, which refers to a game show host. The game show, Let's Make a Deal, was co-created by Monty Hall back in 1963. A Let's Make a Deal game involves a selected member of the studio audience making a deal with a host to win a prize, with the game show's host originally being called Monty Hall. Symbol for the Monty Hall problem. The deal was for the audience member to select one of the hidden prizes, with the entertainment being the audience member did not know what the prize was. Laughs out loud. You could have won the car. You fool. Instead, you won the goat. Looks left. Unless you wanted the goat. Looks right. Yes, yes, this is a special goat, it is Monty Hall's goat. Smirks. The Monty Hall problem was first defined in 1975 in a letter to the American statistician by Steve Selvin. Selvin described an imagined maths problem after watching Let's Make a Deal, which was hosted by Monty Hall. The name of the problem appeared in a follow-up letter by Selvin, which expanded upon his original solution to the imagined maths problem. The Monty Hall problem became famous in 1990, when Marilyn Vos Savant referred to the Monty Hall problem whilst answering a general game show question from a reader who had written into her column. Ask Marilyn, printed in Parade magazine, back in 1990. At the time, Parade was the most widely read Sunday magazine, with Marilyn Vos Savant being known as a woman with a very high, record-breaking intelligence quotient. Gasps. In case you are unaware, IQ numbers represent a person's reasoning ability. Looks left. As a reference, 5% of the world's population has an IQ above 125. Einstein's IQ was around 160. Looks right. Snoop Doggy Dogg's IQ is around 140. Pauses. Marilyn Vos Savant's IQ was around 220. Oh yeah, almost forgot. Spoilers. Smirks. Let us look at the Monty Hall problem as it was penned in the letter to Marilyn Vos Savant. Suppose you're on a game show, and you're given the choice of 3 doors. You pick a door, and the host opens another door revealing a booby prize. The host then asks, do you want to swap your choice to the other door? Pauses. And this is how the question was posed. Pauses. Is it to your advantage to switch your choice? Rolls eyes. Let us not go into the reads just yet. Instead, let us follow Marilyn Vos Savant's answer. Yes. You should switch. The initial choice has a 1 in 3 chance of being the winning prize. However, the other 2 doors have a 2 in 3 chance of holding the winning prize. Since there is now only one other door, it has a 2 in 3 chance of being the winning prize. Given the other door did not have the winning prize. Pauses. You can see the actual answer yourself, and you can see it is weighted to push the reader to accepting the answer of yes. You should switch. Rolls eyes. However, because of the context of the question and the language being used, an argument about the answer Marilyn Vos Savant gave ensued. Pauses. Most people in practice prefer to stick with their original choice, mainly because it is the choice that shows strength and decisiveness. They may also have some pseudo-logic attached, such as 3 is my lucky number. I like the color red, so I chose the red door. Or I picked the door on the outside, because it would be hard to fit a Cadillac into the middle of the studio, plus the doors are not wide enough to have a car in the middle door. I know. I measured it. Smirks. If always switching your choice increases your odds of winning is the answer to the Monty Hall problem, why discuss it further, you might ask. And the answer to that question is that the answer makes a number of assumptions. The host always offers the chance to switch. The host does not switch the prizes on the second choice. The host is impartial or wants you to win. The position of the winning prize is random. The audience member's choice is random. Need I go on? Pauses. The main problem with the Monty Hall problem is Monty Hall. Pauses. Let's Make a Deal is a game show. It is a piece of entertainment, conducted in a studio, with a studio audience. It is not a machine, like a one-armed bandit. The host does not select the prize door randomly. There are other people involved in the game, including stage managers and other people backstage. You could not conduct such a game these days, as it is far too easy to discover and transmit where the winning prize is. Rolls eyes. As for the Monty Hall problem, as a mathematics problem, the reference to a game show misdirects the problem solver. And unless the no prize switching rule is stated explicitly, deliberately creates misunderstanding in the system under consideration. If the system is a mechanical device with the position of the winning prize chosen at random, with a pull of a handle or push of a button, the game theory becomes apparent. Pauses. On the pull of the handle, the device fixes the winning prize. The audience member chooses the hidden prize using a number. The host reveals one of the numbers as a booby prize and offers the audience member a chance to switch numbers. In this game, Marilyn Vos Savin's reasoning can be applied. Always switching your choice gives you a 2 in 3 chance of winning. Pauses. Unless you are lucky. That is, since the probability is based on an average of many games, whilst your game is singular and specific to you. Smirks. Let's look at the mathematics problem from another angle. You have 3 chances of winning, 1 chance is discarded. You have a second choice, switch or stick. Choose 3 cards from a pack. Select a card as the winning card. Randomly select a number from 1 to 3. Shuffle the cards. Place the cards face up. Remove one of the cards that is not the winning card. Switch the chosen number. Does it select the winning card? Now repeat. This time, keep the originally selected number. Does it select the winning card? Now repeat the tests many times. Does either show an advantage? In a perfectly random system, the mathematics will hold. Pauses. The problem with the Monty Hall problem is Monty Hall. Pauses. The practical experiment tells you something about the Monty Hall problem as a maths problem, not the problem described to Marilyn Vos Savant. Rolls eyes. You're on a game show, and the host opens a door you did not choose, revealing a booby prize. The host asks, do you want to swap your choice to the other door? Pauses. Is it to your advantage to switch your choice? Pauses. Does this sound like the Monty Hall maths problem? Modern commentators add the caveat, with all things being equal, and clarify that the host does not alter the prizes behind the doors. Even with those additional conditions, you would need to know if the host always offers the audience member the option of switching. Otherwise, one might suspect foul play, either forcing the audience member to win or to lose, depending upon the attractiveness of the audience member, the finances of the game show, and whether or not 4 or more planets are aligned. Pauses. If I have said it once, I have said it 3 times. Pauses. The problem with the Monty Hall problem is Monty Hall. Smirks. Peace, I am out of here, word up. Exits stage left.
Problem, Monty Hall, Enigma, the Monty Hall. There's all kinds of names that are attributed to this. It has to do with the 3 doors and whether you should, when given the opportunity to get a car behind one of 3 doors, you choose one door. One of the doors is open to show you a goat. 2 doors remain. One is a car and one is a goat. You don't know which one, but you own one of them. And the paradox, I think, was one of the, was, should you keep your door, or if Monty Hall offered you a chance to change the doors, should you change? Now, this started with Marilyn von Savant of Parade magazine, who created this particular problem and said why on the program you should change, and gave all kinds of statistics. The funny part about it is that I don't recall on Let's Make a Deal, once you made your selection and I showed you one of the doors it wasn't, all I did was offer you money. I didn't offer you a chance to then change your door again.